Hello again, everyone. It's time for another weekly episode of Mr. Wilson Teaches Math. That's weird. I usually get interrupted by the... We only introduced new topics on Monday and Tuesday this week, and Tuesday was really just a wrap-up of the unit. So the Week 10 recap should be short and sweet. Recap. The first new topic was inverse trigonometry. So we remember regular trigonometry from last week. In this example, the tangent of angle C is the ratio of the opposite side from C, which is AB, to the adjacent side, which is BC. So that's 21 over 20. And since the cosine of an angle is just the ratio of the adjacent side to the hypotenuse, the cosine of angle Z is 35 over 37. The question we want to answer is whether we can use this information to find the angle measures of angles C and Z. Spoiler, we can. You're already familiar with inverse operations. We use addition to undo subtraction. For example, if you had x minus 4 equals something, you could undo the minus 4 by adding 4 to both sides to find out what x equals. Similarly, you've used division to undo multiplication. We can square root both sides of an equation to undo squaring. We elect Republicans to undo what Democrats did, and then we elect Democrats to undo what Republicans did, and the cycle repeats. And we have inverse trigonometry to undo standard trigonometry. So our inverse trig functions are inverse sine, inverse cosine, and inverse tangent. We abbreviate them the same way we abbreviate the standard trig functions, but we stick a little superscript -1 at the end. We can access those functions on the classroom calculators by pressing the green second key located here before pressing sine, cosine, or tangent. One important thing to understand is that the -1 superscript is written like an exponent, but it's treated like a label, not an exponent. Going back to our example from earlier, I can use inverse tangent to get angle C out of the tangent function. But remember that whatever I do to one side of the equation, I have to do to both sides, so I have to take the inverse tangent of 21 over 20 as well. Inverse tangent and regular tangent just cancel each other out, so angle C is all by itself now. The inverse tangent of 21 over 20 is something we can calculate with our calculators. You get something like 46.40 degrees. We can do the same thing with cosine. I can get the measure of angle Z out of the function by taking inverse cosine of the whole thing. But again, I have to do that to both sides to keep it perfectly balanced, as all equations should be. The inverse cosine of 35 over 37, according to a calculator, is approximately 18.92 degrees. In this example, we're told to find the value of x and round to the nearest hundredth. We're not given a label for the hypotenuse, but we are given opposite and adjacent. So SOHCAHTOA tells us to use the tangent function here. I always start with the definition and look for things to fill in from there. So the tangent of theta is opposite over adjacent. Theta, my reference angle, is just x. Opposite is 12, and adjacent is 9. I'll take the inverse tangent of both sides, and that will cancel out our standard tangent, leaving me with x equals the inverse tangent of 12 over 9. That works out to 53.13 degrees after rounding. The next example is similar, only this time we're given the opposite and the hypotenuse. SOHCAHTOA tells us to use sine when we have opposite and hypotenuse, so I'll write sine of theta equals opposite over hypotenuse. My reference angle is x, my opposite is 20, and my hypotenuse is 22. I'll take the inverse sine of both sides. Sine and inverse sine cancel out, so I'm left with x equals inverse sine of 20 over 22. so x is approximately equal to 65.38 degrees. One last example for this. We've used inverse tangent and inverse sine, so you knew an inverse cosine problem was coming, and here it is. We have the hypotenuse and the adjacent side, so we're going to write cosine of theta equals adjacent over hypotenuse. I'll fill in what I know. Theta is just x, adjacent is 16, and hypotenuse is 18. When I take the inverse cosine of both sides, just like on the last two examples, the inverse function and the standard function cancel each other out. So I get x equals inverse cosine of 16 over 18, or approximately 27.27 degrees. I wanted to show you one more note about notation here. In my class, I always say inverse sine, inverse cosine, and inverse tangent 100% of the time. And I always notate it with the -1 superscript. But depending on what kind of calculator you have at home, you might see the inverse functions written as arcsine, arccosine, and arctangent, abbreviated by putting a lowercase a at the beginning. It's the exact same thing. It's not like when one of you clowns bought me a Pib because it's basically Dr. Pepper. No. In this case, it really is just another name for the exact same thing. I couldn't even finish this. That's it for inverse trig. We also want to talk about solving right triangles. That just takes everything we've done in this unit and ties it together. So every right triangle has 6 parts. There's one right angle, 2 acute angles, 1 hypotenuse, and 2 legs. To solve a right triangle means to determine the measurements of all sides and all angles of the triangle. To solve a right triangle, you need either of the following: any 2 side lengths, or a combination of any side length and any acute angle measure. Let's build a table to talk about what to do with what you're given. Anytime you know 2 side lengths, you can find the third using the Pythagorean theorem, and you can use inverse trigonometry to find both of the acute angles. If you know 1 side length and the measure of 1 acute angle, you can find the other side lengths using trigonometry, and you can find the other acute angle by subtracting the one you're given from 90 degrees, since the acute angles in a right triangle are complementary. So here's an example of a right triangle with 1 acute angle given and 1 side length given. We need to find the other acute angle and the other 2 sides. The other acute angle is easy. 90 degrees minus 52 degrees equals 38 degrees. To find the unknown sides, we're going to use the given angle, in this case angle C, which is 52 degrees, as our reference angle. And we'll use the trig functions that relate the known side to the side we're looking for. Let's look for the length of AB first. That's opposite from angle C, and our known side is adjacent to angle C. So when we're using opposite and adjacent, SOHCAHTOA tells us to use tangent. So tangent of theta equals opposite over adjacent. I'll fill in what I know. Theta is 52 degrees. Opposite is unknown, so I'll just write AB. If you're following along in your notes, first of all, thank you. I'm proud of you. Makes me happy. Tells me these videos are worth it. And second of all, you could just write X if that's easier than AB, but I digress. Adjacent is 19. To solve for AB, I have to multiply both sides of the equation by 19. So AB equals 19 times the tangent of 52 degrees, which is approximately 24.32. Now we'll find AC. So now the side I'm looking for is the hypotenuse, and the one I'm given is the adjacent. SOHCAHTOA tells us that cosine is the one to use for adjacent and hypotenuse. So cosine of theta equals adjacent over hypotenuse. Filling in what I know, theta is 52 degrees, adjacent is 19, and hypotenuse is AC. This time I have to multiply both sides by AC to get it out of the denominator, then divide both sides by the cosine of 52 degrees to get AC by itself. So AC equals 19 over the cosine of 52 degrees, which solves to 30.86 after rounding. Let's do one more example, this time with two sides given. So when it says to solve the right triangle, that means we're finding the other side and the two angles besides the right angle. We'll find the unknown side using the Pythagorean theorem. The hypotenuse is always what goes in for C, but the legs can go in any order. So xy squared equals xz squared plus yz squared. xy is 25, xz is unknown, and yz is 10. 25 squared is 625, and 10 squared is 100. I'll subtract 100 from both sides to get xz squared by itself, and xz squared equals 525. I'll take the square root of both sides, and the yellow calculator will give you 5 square root of 21, but as a decimal, that's approximately 22.91. Now let's find the angle measures starting with angle x. The sides I was given are 10 and 25. 10 is the opposite length, and 25 is the hypotenuse. With opposite and hypotenuse, we use sine, so I'll start with my definition. Sine of theta equals opposite over hypotenuse. Now at this point you might be confused. Mr. Wilson, you might ask, you just said a few minutes ago that we're going to use inverse trig to find the angles, not regular trig. So why aren't you writing inverse sine? Well, that's an excellent question, student I just made up for convenience. You see, it's always easier to just start with the standard one and start trying to solve the equation. Let's fill in what we can. We don't know theta yet, so I'll just write angle x there. Opposite is 10, and hypotenuse is 25. It's at this point that I cannot go further unless I use inverse trig. There is no other way to pull that x out of the sine function. So instead of trying to remember when to use regular sine, when to use inverse tangent, how to write the definition of inverse cosine, just start with the standard definition, and when you reach an impasse, that's when you break out the inverse trig. Only use inverse sine to get an unknown, like a variable, out of the sine function so that we can get it by itself. So I'll take the inverse sine of both sides, and that leaves me with the measure of angle x equals the inverse sine of 10 over 25, or approximately 23.58 degrees. Now we just have to find the measure of angle y, but keep in mind, now that we're using a new reference angle, we're switching which side is considered opposite and which one is considered adjacent. But the hypotenuse never changes. So now we have adjacent and hypotenuse, which appear in the cosine function. So I'll start with the definition. Cosine of theta equals adjacent over hypotenuse. Theta is just angle y, adjacent is 10, and hypotenuse is still 25. I'll take the inverse cosine of both sides to get angle y out of the cosine function. And now I have the measure of angle y equal to the inverse cosine of 10 over 25, which is about 66.42 degrees. So there you have it. That's week 10, and that's our entire unit over right triangles. Make sure you smash that like button like it's a water balloon on top of my head. The cadets know what I mean. And I'll see you freaking clowns after spring break. As always, make sure you smash that like button. And now I have the inverse. Whoa. Hey, what up? I'm Jared. I'm 19. I never learned how to read. Let's look. Yeah. Leaving me with x. Oh, man. We can access them on the classroom calculators by pressing the